In this video, we are going to go over the classic problems of being able to translate from words, word expressions, into compound inequalities. Let's jump into it. There's some keywords here that we've got to learn. We've got the instructions. Write a compound inequality for each phrase. Graph your solution. So we're going to start with an inequality and then we're going to graph the solutions. All real numbers less than -14 or greater than 12. If it's or, we've got one inequality or another one. They're two separate inequalities. So what does that mean? Well, all real numbers, let's just call x. So we have all real numbers, x is less than -14. That's that statement, translating as we read, or greater than 12. So I literally state the word or and have x be greater than 12. That's our inequality right there. X is less than -14 or x is greater than 12. Straight up translation. So what does the graph look like? Well, remember, with or, we have two different directions. We graph each inequality separately, and both exist on the same graph because either we've got numbers less than -14 or they're greater than 12. So I'll start with this inequality. -14, it's an open circle because it's just less than, and it's all numbers less than -14. Or x is greater than 12. So I'll throw down a 12 with an open circle because it's greater than, and shade all numbers greater than 12. That is what our graph looks like. All the numbers less than -14 or all the numbers greater than 12. Sweet. On to the next one. All real numbers between -5 and 0. Now it says between, but it does not say to include -5 and 0. So what that means is we want all the numbers in between them, right? Another way of putting this is all numbers that are greater than -5, if we're between -5 and 0, and less than 0. So we want the overlap of the numbers. So we can write that either as x is greater than -5 and x is less than 0. You could write it that way. We could also write it, and this is how I like to do it, combining them. -5, if x is greater than -5, you can write it this way as well. X is greater than -5 and x is less than 0. And it gives you that idea that x is between -5 and 0. Again, we don't include -5 and 0, so no or equals to, because it's just a number strictly between them. Now graphing it looks a lot like how our symbols look. So I always thought and was a little easier to understand to graph personally, because we look like we're containing x between two numbers. So I have -5 and I have 0. And we're going to have open circles on both of these boundaries because neither are or equal to. And we will shade everything in between because we want all numbers that are more than 5, and less than 0, which is everything in between them, but not including them. All right, on to the final problem here, which is the same as this one. And when I say the final problem, on this clip, on the other side of this video, I've got two more bonus problems for you just to make sure that we go over all the different kinds of examples you could be exposed to. Anyway, all real numbers between -5 and 0 inclusive. This is almost identical to this problem. So it's still -5 is less than x, which is less than 0, because that gives you all the numbers so that x is more than -5 between it, right? And less than 0, but we're including -5 and 0. So we have or equal to there. How does that change the graph? Well, you literally take this graph here, the very same graph, because you have the same endpoints for the same reasons at -5 and at 0, and include the endpoints because we have or equal to, inclusive. And then we want all the numbers in between. Nice. On the flip side of this video, two more examples, same exact instructions, just so that we cover all our bases and you could rock any problem that comes your way like these. And here we are on the flip side of this video where we're going to be going over how to rock translating word expressions into compound inequalities. So on to D. It says the temperatures last June were at least 87 degrees Fahrenheit, or, there's the key operator, or less than 82 degrees Fahrenheit. So this is an or inequality. So I'm going to write out my inequality here. If the temperatures, we'll call that T, were at least, that means that we were at least greater than or equal to 87. That's one heck of a long or equal to sign. So they were at least 87, or they were strictly less than 82. So that's saying T is less than 82. And we're letting T be the temperatures. So what we can do now is graph it. And one thing to point out is when we're doing the compound inequality with or, we don't overlap the inequalities at all, even in the notation. They stay separate from each other, whereas and overlaps together. So we'll start with, I guess I'll draw 82 because that comes first in the number line to the left, and then 87. We had temperatures more than or equal to 87, so they were at 87, closed circle, or more. There we have it. Or they were strictly less than 82, so not including 82. And there we go. There is our graph. Not bad. I saved the best for last, in my opinion. All numbers greater than 4 or no more than 6. Let's check this out. This one's going to be an interesting one. So we'll write it out. All numbers, let's just call the number x. So that would be greater than 4, just translating as I read, or no more than 6. If you're no more than 6, you're at 6 or less, which would be x is less than or equal to 6. Well, let's think about this. I want all numbers that are more than 4, okay, so it'd be not including 4, but everything after, or numbers that are at 6 or less. That's all numbers. Any number works for that, right? If I pick 5, that's more than 4, and it's less than or equal to 6. If I pick 17, that's more than 4, and even though it's not less than or equal to 6, it satisfies it. So all numbers work for this. Nice. So what's our graph going to look like then? That's the interesting part. This is something some textbooks don't go over that I wish they did. Well, you have x is greater than 4, and I'm going to actually graph them both out to understand this. It's or, so that's all the numbers greater than 4, and then 6 is somewhere like right here. Let's just put it arbitrarily, and then we could close the circle there at 6, and we'd shade everything to the left. Notice that both graphs overlap each other completely. There are no holes. Even the open circle of the 4 gets shaded in when we're doing numbers less than or equal to 6. So the answer here is that all real numbers work, and you're shading the entire number line. It's not a problem to memorize. It's a problem to result to. What I mean by that is trust that you're able to graph out or inequalities, and the result ends up coming from your work. Not, I'm going to memorize what to do here and recognize the situation. That's not math. Super sweet problems, guys. Go rock some more.